Good morning, geometry. So yesterday I gave you a couple of problems to try, and some of you got them and some of you didn't, and that's okay because I'd never really talked about them before and I wanted you to try to discover some things on your own. But today let's talk about them. So the thing is, we were talking about a very, very particular kind of right triangle. And we were talking about a right triangle where the two legs were congruent. In other words, it was an isosceles right triangle. So something like this, where one leg is 2, another leg is 2, and you were trying to figure out the hypotenuse. But I actually gave you 2 questions. The first question was, hey, what's the deal with those angles? So let's think about this for just a little bit. If these 2 sides are the same, then it means that these 2 angles have to be the same. And since I know that all 3 of these add up to 180 degrees, and that much of it is 90, these 2 together have to equal 90 degrees, which means that each one of them has to be 45 degrees. Okay, so this kind of an isosceles right triangle, we have another name for it. We call it a 45, 45, 90. Because the 3 angles are 45 degrees, and 90 degrees. Okay, so yesterday, really what we were talking about were 45, 45, 90 special right triangles. Special because they have this really cool characteristic where 2 of the legs are the same. Okay, so my question was, what's the length of the hypotenuse? So let's take a look here. If I want to find the length of the hypotenuse, I'm going to go straight to Pythagoras. And I'm going to say that 2 squared plus 2 squared is equal to my hypotenuse squared. 2 squared is 4, 2 squared is 4. So my hypotenuse squared is equal to 8. If I take the square root of both sides, then I'm going to get that x is equal to the square root of 8. But I did say put that into simplified form. 8 has a perfect square factor, and that's 4. 4 times 2 is 8. So this is the square root of 4 times the square root of 2, which is 2 root 2. So this guy here is 2 root 2. Look at that. 2 root 2. That's kind of cool. Let's try another one. What if this is 3? So this would be 3 squared plus 3 squared is equal to my hypotenuse squared. That's 9. That's 9. So 9 plus 9 is 18. X squared is equal to 18. Take the square root of both sides. X is equal to square root of 18. But 18 has a perfect square factor, and that's 9. Square root of 9 times the square root of 2 gives you square root of 18. But the square root of 9 is 3. So this is 3 root 2. Oh, looky there. 3 root 2. Now that pattern is only going to work for an isosceles right triangle or a 45, 45, 90 triangle. So if you have this situation here, I know this is an isosceles right triangle because look, it's right, and look, those are the same length. I don't even have any numbers on this last problem. So I'm going to call this guy here X. I'm going to call this guy here X. And you know what this is going to be? Oh yeah, X root 2. And that means a number times another number. Whatever that X is, times the square root of 2. Which we can have as a decimal approximation is like 1.41 something, right? Okay, but X root 2. Okay, so now let's pretend. If this is 7, this is 7, this is 7 root 2. And all of this stuff here that I used to have to do, all that Pythagorean theorem, I can shortcut it. I can go straight to the hypotenuse. Here we go. X root 2. That's what you got to remember. X root 2. Okay? I want you dreaming it. X root 2. Peace.